There are other patterns and trends that occur on the periodic table that affect how the chemicals or elements interact with each other. The first one's atomic radius. This is the size of the atom. It's measured from the distance between the nucleus in the center to the electron cloud on the outside. Atomic radius changes as you go down a group. It increases. So as you go down the periodic table, the radius is going to increase. Why? Because there are more electrons. If you think about what happens in the first period, there's one shell. In the second period, there's two shells. In the third period, there's three shells. So as I add more layers, the atom has to increase in size. As you go across the periodic table from left to right, the size is going to decrease. Why? Because the radius contracts as the charge increases. If sodium has 11 protons in its nucleus, magnesium 12, aluminum 13, and so on, these protons in the nucleus are attracted to those electrons on the outside. The more protons I have in the nucleus, the stronger the pull is in towards the center. Ionization energy is the amount of energy required to completely remove an electron. Remember that if you remove an electron, you cause the atom to have a positive charge. The first ionization energy is the only one we're going to focus on here, and it's the energy required to remove the first electron. But do realize that you can remove more than one electron. As you go down a group on the periodic table, the ionization energy is going to decrease. Why? Because the electron is further away from the attraction of the nucleus. Look at the size of these atoms. If the electron we're removing is in the valence shell on the outside, the one that's going to be the easiest or the least amount of energy to remove is the one that's bigger. How does ionization energy change as you go across the period? It increases. So as I go from left to right, the energy is going to increase. Why? Nuclear charge is increasing. Remember that those atoms are more attracted, or the electrons are more attracted to the positive charge in the nucleus. The other reason, a good way to remember, is that if you think about the periodic table, we said ionization energy was going to have a positive charge. Positive charges are on this side. Negative charges are on this side. So the atoms over here want to gain electrons, not lose them. Just as a reminder, that's not the reason why, but it is a good way to remember it. Electronegativity is the tendency for an atom to attract electrons to itself when it is chemically combined with another element. The important thing to remember is that they are trying to attract electrons. Remember that attracting electrons or gaining electrons would give you a negative charge. How does electronegativity change as you go down the group? It's going to decrease. Atoms that are larger are less likely to attract an electron because they are further away from the nucleus. Remember the size as they get bigger. My nucleus is all the way in here. It doesn't have the power to pull in another electron. How does it change as we go across the period? It's going to increase. Why? As the charge increases, there's more attraction. Plus, the nonmetals want electrons. Like I just said, things that are on this side of the periodic table want the negative charge. Things over here want to be positive. They want to lose their electrons, not gain them. So over here, remember those electrons or the atoms are much smaller, so they're more likely to attract electrons. So the trends, atomic radius, these arrows show the direction of increasing. So they increase as you move from right to left. Larger will be over here. And then going down, the larger are at the bottom. For ionization energy, it's the opposite. The ones with higher ionization energy are on the right and towards the top. For electronegativity, we don't include the noble gases because they will not attract electrons and they're not going to bond with anything. So the highest electronegativity is going to be fluorine. Circle the atom that has the larger atomic radius. Well, if we are looking for larger, it's going to be the one that is to the right and down, or left and down, sorry. Left and down. So when you're looking at a periodic table, lithium is more to the left and potassium is more towards the bottom. For ionization energy, you're looking for the one that's lower. Ionization energy increases as you go to the right and as you go up. So the lower is going to be left and down again. So looking at the periodic table, aluminum is lower on the periodic table and sodium is more to the left. For electronegativity, we're looking for the one that is higher. Electronegativity increases to the right and going up, so higher is going to be right and up. Looking at the examples, the one that's higher is oxygen and fluorine is more towards the right.